So, hi guys! Welcome back to my YouTube channel. So, for today's video, I'm gonna show to you on how will I answer the Chapter 5 activities in Cisco Networking Academy, and at the same time, on how will I explain it. So, without further ado, let's begin. So, this is the first activity in Chapter 5 of Cisco Networking Academy. And this activity is entitled MAC and LLC Sublayers. So, according to its instructions, descriptions of the MAC and LLC sublayers are provided in the table. Click in the MAC or LLC fields to match the descriptions to the correct sublayer. So, these are the hacker characteristics. Controls the network interface card through software drivers. Works with the upper layers to add application information for delivery of data to higher level protocols. Works with hardware to support bandwidth requirements and checks errors in the bits sent and received. Controls access to the media through signaling and physical media standards and requirements. Supports Ethernet technology by using CSMA or CD or CSMA or CA. And the last one is remains relatively independent of physical equipment. So the answer for the number 1 is LLC or the logical link control. And the next one is also LLC. The third one is MAC or the media access control. Also the fifth and the fifth one. And the last one is for the LLC or the logical link control. So let me explain to you what is the media access control. So media access control is a sublayer of the data link layer in the 7-layer OSI network reference model. So MAC is responsible for the transmission of data packets to and from the network interface card and to and from another remotely shared channel. So the basic function of MAC is to provide an addressing mechanism and channel access so that each node available on a network can communicate with other nodes available on the same or other networks. Sometimes people refer to this as the MAC layer. So next is the logical link control. So logical link control is one of 2 data link layer network protocol sublayers within the Open System Interconnection or the OSI data communication model. So it is located in the upper data link layer area of Open System Interconnection Layer 2 above the physical layer of OSI Layer 1. So LLC or the logical link control is standardized as IEEE 802.2 by the Institute of Electrical and Electronics Engineers or the IEEE. So today LLC is only used for multiplexing feature. Modern transport layer protocols like TCP or other application layer protocols are used for source and destination network flow management. So this is the second activity in Chapter 5 of Cisco Networking Academy. and it is entitled as Identify Ethernet Frame Field Names. And according to its instructions, drag the 802.3 Ethernet frame field name to its description. So let us answer this activity. First description uses pad to increase this frame field to at least 64 bytes. So the answer is 802.2 header and data. Next one is describes which higher layer protocol has been used. So the answer is the type. So the type field is 2 bytes long. This field stores information about the protocol of the upper layer or the network layer. So the data link layer of the source computer prepares, packs, and loads the Ethernet frame in the media. The data link layer of the destination computer picks the Ethernet frame from the media. After picking the Ethernet frame, the data link layer of the destination computer unpacks, processes, and hands over that Ethernet frame to the upper layer for further processing. And the next one is the source address. So its description is the frame's originating NIC or interface MAC address. So for the source address, this is a 6-byte field which contains the MAC address of may I repeat again? So this is a 6-byte field which contains the MAC address of source machine. A source address is always an individual address or a unicast. The least significant bit of first byte is always 0. So next is the destination address. It assists a host in determining if the frame received is addressed to it. So a destination address is a 6-byte field also as compared to a source address, which contains the MAC address of machine for which data is destined. So the next is the preamble. So preamble notifies destinations to get ready for a new frame. So Ethernet frame starts with 7 bytes preamble. This is a pattern of alternative zeros and ones which indicates starting of the frame and allows sender and receiver to establish bit synchronization. Initially, preamble was introduced to allow for the loss of a few bits due to signal delays. But today's high-speed Ethernet don't need preamble to protect the frame bits. It indicates the receiver that frame is coming and allow the receiver to lock onto the data stream before the actual frame begins. So the next is the start of frame delimiter. So it synchronizes sending and receiving devices for frame delivery. So this is a 1-byte field which is always set to 10101011. So it indicates that upcoming bits are starting of the frame, which is the destination address. And the last one is the frame check sequence. It detects errors in an Ethernet frame. So this field is 4 bytes long. It stores a 4 bytes value that is used to check whether the received frame is intact or not. So this is the third and the last activity in Chapter 5 of Cisco Networking Academy. And this activity is entitled as Frame Forwarding Methods. And according to its instructions, descriptions of switch frame forwarding methods are provided in the table. Click in the Store and Forward or cut through fields to match the methods to the descriptions. So, first is the descriptions. the first one is buffers frames until the full frame has been received by the switch. So the answer is store and forward. Checks the frame for errors before releasing it out of its switch ports. If the full frame was not received, the switch discards it. The answer is store and forward. Number 3, no error checking on frames is performed by the switch before releasing the frame out of its ports. The answer is cut through. A great method to use to conserve bandwidth on your network. Store and forward. The destination network interface card or the NIC discards any complete frames using this frame forwarding method. Cut through. And the last one is the faster switching method but may produce more errors in data integrity, therefore, more bandwidth may be consumed. The answer is a cut through. So, let me explain to you what is a store and forward. So, store and forward switching means that the LAN switch copies each complete frame into the switch memory buffers and computes a cyclic redundancy check or CRC for errors. CRC is an error checking method that uses a mathematical formula based on the number of bits in the frame to determine whether the received frame is errored. If a CRC error is found, the frame is discarded. If the frame is error-free, the switch forwards the frame out the appropriate interface port. And the next one is the cut-through switching. With cut-through switching, the LAN switch copies into its memory only the destination MAC address, which is located in the first 6 bytes of the frame following the preamble. So the switch looks up the destination MAC address in its switching table, determines the outgoing interface port, and forwards the frame to its destination through the designated switch port. So, it was developed to reduce the delay in the switch processing frames as they arrive at the switch and are forwarded on the destination switch port. So, I think that's all, and I hope that you can get some information from me regarding this activity, and so that's all, and thank you for watching.